All right, it's about 1:03, so I'm going to go ahead and get started. Thanks everyone for coming today. Here we go. My name is Savannah Tracy. I'm the communications manager at the Cleveland Water Alliance. We're really excited to partner with Dr. Ting Liu of Clean Water Services today on her webinar, Transforming Holistic Watershed Management through Digital Solutions. Before we begin, I'm just going to take a couple seconds to talk about the Cleveland Water Alliance. So some background information on us. Cleveland Water Alliance is a water innovation cluster based in Northeast Ohio, but we work Lake Erie region-wide. We recognize that water is one of Northeast Ohio's most abundant and precious resources. The Great Lakes contain 20% of the world's surface freshwater and drive billions of dollars of economic revenue and growth each year. So the Alliance is a nonprofit organization that collaborates with a cross-sector of partners to really accelerate implementation and commercialization of new innovative technologies in the water space. Our mission is really to foster this robust Northeast Ohio water innovation and technology ecosystem of economic development, commercialization through partnerships with industry, academia, and government institutions. For us, that looks like a couple of different key program areas. So the first one is what we called Innovate. These programs are about the development and implementation of new technologies, whether that's research, academic, or in the private sector context. The next piece of our programming is the connection between innovators in a broader innovation ecosystem. Cleveland Water Alliance serves as a hub for the Lake Erie region to connect research institutions with private companies, with utilities, with incubation services, in order to de-risk the process of innovation and accelerate the time it takes for technology to move from the R&D phase to real technologies with impact. And the next programming area that we focus on is something that we called Elevate. This really gives Cleveland Water Alliance the capacity nationally and internationally to talk about Lake Erie and the Great Lakes as a hub for this kind of innovation and technology. We bring partners and collaborators like a lot of different kinds of corporations and government agencies and nonprofit organizations into new spaces and offer them new opportunities by using Cleveland Water Alliance as a platform to elevate the narrative around water innovation, the blue economy, and the significance of these things. So this slide is just to quickly talk about and give a sense of the kind of partners that we have engaged. So a big part of this is industry. That's a huge core of our collaboration. A lot of our members are engaged in innovation from the corporate perspective, but we also work really closely with utility, academic, government, nonprofits, and foundations. These are all supporters who are committed to engaging in the innovation ecosystem. So with that, it's my pleasure to introduce Dr. Ting Liu, who will be presenting the webinar today. Just a reminder that we will be doing some Q&A at the end. So if you have any questions, feel free to submit in the question box as we go through the webinar today. Dr. Ting Liu is the business practice leader for digital solutions at Clean Water Services in Hillsboro, Oregon. Ting leads and directs innovation of digital solutions and oversees day-to-day IT implementations and the implementation of data management and IT and OT integration. So with that, Ting, I'm going to let you take it away. You can go ahead and start sharing your screen.
Thank you so much, Savannah. Can everyone see my screen okay?
Yep, you're still got the both.
Here.
There you go.
This better?
Yep.
Thank you, Savannah. Hi, everyone. Thank you so much for having me here. And I actually graduated from University of Cincinnati, Ohio, and have been in Ohio for more than 10 years. So this has been really refreshing to share with my stories with the Midwest and the Cleveland Water Alliance partners together. I know Cleveland Water Alliance is a key leader in watershed management. So today I will also talk about our story on transforming holistic watershed management through digital solutions in the Pacific Northwest. Agenda for today is a little bit technology evolution for the last 40 years, so things has really changed. And also some of the background with the utility. I'm working with clean water services and what are the drivers for digital transformation. Followed by 3 case studies that how we use IoT sensors, open source, cloud solutions, and data analytics to helping us protect and manage watershed holistically. And finally, some of the transformation journey and the values and lessons learned I like to share with everyone. The first, I think, I'm not sure how many people remember this. This is the early 1980s that the magazine Byte first announced the personal computer has arrived. So soon after that, they have found ways into the enterprise network together and eventually connected to the World Wide Web. And after, for the last couple of decades, the analytic power really has been just exploded with all the remote sensing technologies through satellite imagery, artificial intelligence, machine learning, and then the cloud data analytics is enabled the big data analytics to provide that business intelligence for organizations and other industries. So this is a survey that Gartner, as an organization, they are leading research and advisory agency for IT field. So they have done a survey for the CIO agenda. And I want to point out here for utilities on the first left column you see, it's all the top 5 is data analytics, including predictive analytics, artificial intelligence, IoT, machine learning, cloud and automation. So this also we keep hearing from the water sector. So it's really nice to see how water sector has been more engaged in looking to these innovations regarding technologies. You can see it's also aligned with the private sectors pretty closely as well. So this is the whole industry, the IT industry, the technology trend. And now coming back to the Pacific Northwest, the Clean Water Services, we are a regional wastewater and stormwater district working with the 12 other member cities. So you see here the downtown Portland, city of Portland in Oregon. So we are right outside of a downtown and managing the whole Tualatin watershed here. So we serve a population around 600,000 with 4 water resources recovery facilities with the typical municipal stormwater MS4 format program. We also do river flow management as well as the regional flow supply planning. And just like typical utilities, we do pumps, pipes, and plants, and we also using innovation to improve watershed health. And anything that we do is really looking towards the outcome of watershed health and community benefit. So we, some of this I want to highlight is we are the first one in the nation to start with the resources recovery for recovering phosphorus as a fertilizer. It's a more sustainable fertilizer that you can buy from Amazon today. We also produce Class A reuse water for irrigation on farmlands, and also worked with a local brewery to produce beer from the high purity water. So this is really to help jumpstart that conversation about the potable reuse and get rid of the public yak factor. We are also continuously working on the long-term water supply. In part is in this region, we augment the summertime flows in the river. And as a part of the watershed management, we implement over 100 miles of riparian restoration planting project across the basin, and then encouraging wildlife. And also we have the natural treatment system. So our strategy for watershed management really integrate gray, green, and the natural treatment system together. Before I get started with the digital solutions innovation, I want to talk about the regulatory framework, because a lot of this is driven by the regulatory framework. And I put a question mark first because sometimes people don't see these two go well. It's the regulation framework. And I want to say that it can be done. It's not easily, but the end result is really important to set the foundation for that holistic watershed management. So for us, we have been developed the first watershed-based permit with two innovations. The first one is water quality trading that enabled water quality trading with the temperature. We have a temperature requirement for the discharge effluent, and trading provides us that flexibility to use restoration and flow augmentation to lower the temperature to protect the fish and the watershed instead of installing a mechanical chiller at the end of the plant, which is a huge environmental benefit. Also, the second innovation is we have this mass bubble loading on the conventional pollutants, including TSS, ammonia, and phosphorus together. So the benefit of this mass bubble loading really provides us that flexibility to optimize the whole watershed. So some of the plants that have the minimum land that could be the limited footprint to expansion, while other plants have more flexibility in the land. So it enabled us to optimize the system as a whole, which also provides the opportunity for chemical and energy cost reduction. This watershed-based approach also allows for support for a more complex TMDL to truly working on the sources of pollutant loadings besides just the point source, and working with the non-point sources together on restoration projects. And this also helps with the just shift overall as a conversation on the watershed scale management. So now I'm going to talk about 3 case studies that's related to the drivers, the regulatory framework, and some of the challenges we face. The first one immediately, as you can see, to offset the thermal load to the receiving stream, we implement the stream restoration project and tree planting to help generate the shade to keep the rivers cool. So now the questions become, how do we monitor this large 100 acres of a project, and then understanding the impact to the receiving stream? So before we use this densimeter, so you can see this is the person goes out to the site and reporting the shade. And then, I mean, one person can only go to the selected site, and we use that as an estimate to say this is the overall shade we are providing. But now we started to using LiDAR remote sensing technologies to monitor that entire watershed at one time. So you can see this is the whole watershed monitoring on riparian planting progress. So which is a more objective, and the value of this, so we can actually monitor the entire watershed and truly report on the shade coverage, the thermal load that we are able to offset, and it just provides a much more accurate method to tracking project success. So this with that large scale, reliable, and objective monitoring, the stream restoration projects are mapped out in the GIS system to see the shade coverage, and this enables us to identify the gaps in the project area and also what we need to continue planning for the over years. So through this map, you can see between 2007, and that's the purple area, the orange area, and 2014 is the additional shade coverage, the purple area. So that's much more additional coverage throughout the watershed. One thing with the LiDAR is it's great for tree planting monitoring because the tree doesn't really grow that fast. So we have this LiDAR fly over every 5 to 7 years, which is perfect for riparian trees. But for some of the other vegetation growth, and also some of the green infrastructure, it limits the capability to track growth in a more frequent manner. So in 2016, the district began to pilot the UAS or drones fly over to monitor vegetation growth. So today we have 3 drone pilots who can fly drones whenever we need to really providing that higher resolution 3D imagery to look into the area in a more larger scale. So there is also additional data could be collected besides just the imagery, area imagery and the vegetation progress. So this is some of the derivatives of using drone flyover captured with the multi-spectrum camera with the vegetation index and health. So the top right one shows you the really impervious area derived from the drone flyover imagery. How much area is actually vegetation versus how much is still the green space or other land use covers. And the other piece is that using this imagery, we were able to look into the vegetation health, whether the ground shows really this is not healthy vegetation versus there's a low, mature, and impervious area in the area. So this really helps us not only just on the watershed project monitoring, but while we're looking to the project, even the infrastructure project, what do we need to implement to support on the stormwater runoff and other things. Through the point cloud data and open source software, we have also built in the 3D model. So these are some of the applications continue to derive from the drone flyover imagery. So this imagery shows you using the flyover imagery, we were able to calculate the channel width and depth and understanding some of project information, erosion control progress over the times. This one shows you the calculation with the 3D model to see what the tree height is in the area. The third one is we use the drone flyover to help us to estimate and calculate the volume of the detention pond we are implementing. So think about, you have to, before you have to send a surveyor to do all this surveys and take quite some time. Nowadays, we could be using the imagery we already done and derive a lot of the information from there. Then the second one I want to talk about the stormwater management. It's related to also the watershed perspective. Is the question or the reason why we're looking to technology. The first, here we have a regulation requirement on hydro modification because of the land use change and the population growth. So we're required for the pre-development hydrographic peak to match the post-development peak based on the regulation. But the integrated approach we are taking is we're using some of the upland control to optimize and implement some of the existing green infrastructure performance to hold that water for flow reduction detention. But we are also, as you heard earlier, using stream restoration, riparian planting to really quickly dissipate that energy and reducing erosion. So it's an integrated approach to really get to that, the urban, stable, and the resilient stream without taking too much infrastructure upland to do all of this controls. So how does technology fit here? This is the urban area that a lot of development, as you can see, and then we used the strategies, the stream restoration project is along the rivers, the creeks here, to really increase that resiliency and stability of the stream. And also for the development project, and we have a detention pond. The opportunity here is to using a technology to optimize this detention pond, because the detention pond is, if it's just a default pond, it's just what comes in and it's going to be released eventually. It's a passive control, and you really don't know what's going on. So through technology, collaborating with the OptiRTC, so we have used this technology to actively controlling the release of the pond release. So this is the rain gauge that you will see, you will understand what's the rain coming to the region, and weather data coming from the NOAA, and some of the camera to see what's going on remotely, and through real-time analytics and cloud computing to automate this flow release. So the general logic is actually pretty straightforward. So it's really looks and anticipating if there's a forecast with the rain precipitation, and then the system getting ready to hold this water, and then they will release at the minimum rate during the event, with the hope to holding this water as much as possible, but still making capacity available for this whole rain event. And then once you're getting to the dry weather, you release within an allowable time frame, and then the system is continuously adapting to the current state and the forecasting to get ready for the wet weather event. So this is a cloud solution with the Opti, as I said, and integrating sensors and the forecast and the data analytics to predict the levels and visualization, so we can see it remotely from our office. So this is the performance you can see over a few weeks, and we have a few rain precipitations throughout the couple weeks. And then this is the incoming flow to the pond. So it's pretty matching what the rainfall is coming. So if you don't have active control, it's really the outflow of this pond is going to matching this inflow to the pond. But with this active control with the Opti system, we are able to really mitigate multiple peak rainfall runoff events and really produce that flat flow hydrograph in the receiving stream. And this really provides that resiliency and stable energy for the receiving streams. So where we are headed is coming from a pilot, and we have done this a few years with Opti, and eventually we like to get into a watershed scale implementation. There are quite some retrofit opportunities we already have, and also integrate this as a part of the overall stormwater management strategy within clean water services. So we have this not just individual Opti system, but it's a system itself, and incorporating receiving stream, rivers, gauges, and flows. So we are incorporating weather forecast and the receiving streams, and truly optimize the system on the watershed level. This will greatly helps with the adapting and the improved performance over time and reducing the runoff. The third one is the more on the operational side for real-time operation maintenance for how we use IoT sensors. So this one shows the GIS platform showing the sanitary sewer sensors. Then we built in some calculation here, and then you can see the water drops are showing in the rain gauge, showing what's coming to the rain region, and then this different levels, and it's going to show a different color. So if it's a red and it's the triangle trending up, so this is something that field operations group is really needs to look into quickly, versus it's green and it's flat. So this is the day when I did the snapshot. It's the system pretty stable and pretty flat. So this is a way that to help our field operation crews to see, oh, there's a rain coming and there is a trending up with the sanitary sewer system. We need to come here to really see what's going on. And also the same similar information, the real-time vehicle location is mapped out on the GIS map as well. So you can see where the crew is at and to prioritize their workload based on what's coming to the system from the previous map. The third one is we started looking to the open source platform to really bring all this information together. What I see the challenge before is we have a different software packages and the information is pretty siloed. I'm calling those the digital silos. So it's great for one group to look into the rain and sanitary sewer information, but then from the receiving stream gauges, and it's stating a different system. So this is a research project we collaborate with the Oregon State University on bringing all this heterogeneous data together to really tell a story, to correlate different type of data together. So this is snapshot, and this is a heat map showing the flood complaints in the region. So you can see some of the areas with the really extreme red, and shows there is some flooding issues going on for the last few 15 years. And also on the left corner, it shows the stream gauges, stream flows in this basin, as well as the rainfall precipitation coming to this region as well. So you can see, once you see this overall 14 years of the data, you can see the correlation, and it helps to look if there is a potential I&I, we can come back and look at this data in one platform together, versus before people just have to download the data from different systems, and it takes quite a while, the information and time. So this is also the top bar shows the level of flood complaint cost. The higher the bar shows the higher the complaint cost during that time. So this correlates pretty well with the precipitation stream, but not all the time, which really inspires deeper question for the internal team members to say, why is that? What's going on in this basin? So it's pretty powerful when you look at data analytics and visualization, just to bring all the data together. And this provided really data-driven visualization and interoperability with other systems. And also it's visible and it's storytelling. You could really hosting this to your public for as needed for information sharing. So now I will talk a little bit about our journey for transformation, the things we learned. With the integrated permit, with the integrated strategies, we continue to see challenges ahead. And I think this is very common to other regions in the country. So we see we are working on the stormwater phase 2 permits with a lot of municipalities in the area. We don't have a CSO consent decree, but we do occasionally have some of the sanitary sewer overflows and the pump station overflows. As I mentioned, the hydro modification requirement is a big one for the district. I think the nutrient issues is a universal for Ohio and for other places, and causing this harmful algal blooms that how do we using analytics to monitor that? Just like other utilities, our infrastructure is also, some of those are aging for 40, 50 years old. One of the big driver for us is the population growth in this area. It's a high-tech area with Intel and the Nike, the headquarters here, which is great for economic growth, but also how do we keep up with the development and providing that infrastructure and the future needs has been always the top priority for us. as I mentioned, we're engaging the water supply for long-term water supply, but then that's also connected with the weather change, and we see this extreme drought conditions in summer, and also this really slushy flooding issues in the area too. So the digital solutions is the group we're really working in, and this is formally our IT department. So the mission for digital solutions really addressing the skills, regulations, and asset management issues. First, I see it's important is to maintain that reliable and up-to-date foundational system and the infrastructure, that including all your network, your security, your database, and the system applications. And because that's the foundation, you can perform a lot of advanced analytics and visualization. The next level is really for operation optimization to optimize the basin planning and the risk management through technology integration to really maximize that existing capacity, performance, and extending that asset life before we get to the capital project. And then just day-to-day, and the digital solutions providing business intelligence for the quantitative decision support. This is a snapshot of we are actively using Power BI to helping with a lot of the key performance indicators for the district. So the digital transformation to me really starts with the culture change first. So for us, last year we transformed as I said, the IT from a hierarchical organization to an agile CWS Digital Solutions. And I look at this as breaking that silos, and it's a network of talented individuals, software engineers, and program analysts, and database administrators, and the business analysts and business units are all working together to co-create that solutions together. So leadership only provides the directions and enables action, but it's the team members truly to working together, build that end-to-end accountability with the quick changes, agility, and the flexible resources. So the framework, from an integrated framework standpoint, we're trying to integrate these silos together to really see that holistic solution and story to begin to do decision support. The challenge with the utilities I see is that we have this all different softwares, whether it's sanitary sewer sensors, catalog system, and data warehouse, and the SWIM or asset management. We have Blue City. This is quite a jungle. I think one time I heard someone describing this. It's really limited sharing and analytics. It doesn't really give you that whole picture of what's going on. And then through transformation, we are building this integrated digital CWS framework that is really impacting the whole landscape on watershed outcome. So you can see this the gray, green, and the natural treatment systems. So these are the assets. Then we're using sensing and control to understand characterize the system. And I know sometimes people call this the digital twin as well. And then there are quite a lot of opportunities I see with the collection and the network communication in recent years with LoRaWAN and other network communication protocols, and getting down to the data management and access. So this is a huge one for data integration, and also just data quality and QA/QC. There is still a lot of work and opportunities for data management, and getting down to some of the analysis, advanced analysis, and also statistic analysis and visualization, as I showed. I see a lot of different capabilities in open source with 2D, 3D visualizations to help tell that story. So this has started to become more collaborative, and people. Really, it's the biggest asset is for our team members to working on all this together, making holistic and informed decision support. So as I mentioned, it's the first to cultivate a data-driven culture and develop the integrated framework. As I said, we have been having a data management hub that brings across the district different departments to sharing data, sharing how do they transform data into information for the last 3 years to really getting people started to understand the data, the importance of data. The second I see is it's important to align digital solutions transformation with the district mission innovation together, because the digital solutions really is about technology, and this needs to further enhance the organization's mission innovation. So that I see is being part of that bigger picture and understanding what you're trying to accomplish on the outcome level helps. The third one I see is very important is to develop a digital solutions ecosystem partner with both internal, your business units, your wastewater department, collection department, regulatory department, and also externally, there's a lot of a great technology provider, consultant, and actually I really enjoyed sharing this, and hopefully we'll have some good Q&A to discuss this together. I believe in an ecosystem partner approach to addressing problems. And then once you have this, and it's really co-creating this vision together that to meet the organization's overall mission innovation, because the IT or technology can't do it just by yourself. It really needs to understand the challenges and what we are trying to solve. We are in the process of developing a roadmap with the KPIs and also building blocks to accomplish this digital solutions transformation. So here are some of the building blocks we're developing for the next couple of years. The first is the cybersecurity, as we are embracing more technologies, open source IoT sensors, developing a cybersecurity roadmap to addressing the security issues. We're also working on data management strategy with all the data that's coming to us. What's the holistic strategy, incorporating data governance, quality, platform architecture, and the data operations together. We are actively piloting and trying low-cost, reliable IoT sensors to provide more quantitative data points for information. The first one is we're looking to a lot of the integration with API interoperability with other systems. We're also evaluating value-added cloud-based solutions, database and servers, and to see how does that further enhance our capabilities and also free up some of the time for brainstorming additional ideas for our team members. I know a lot of people are always trying the new technologies, and this is some of the considerations I thought I would share while we are using technologies and data. So the first one I see a lot of technologies when we bring in-house, including OptiRTC, we do a pilot scale evaluation, and I found that's very beneficial to understand the risk and how do we addressing the issues coming on board. The second one is to consider balance in-house expertise and external outsourcing stuff. So it's really a good business case. This is very helpful. And when you're looking to digital solutions, and usually you just hear one thing with the capital cost or initial cost, but consider all this additional layers, data storage, sensor maintenance, and calibration, all this ongoing O&M costs you might not be aware of at the beginning. And then try to consider integrate system together as much as possible to really optimize on the watershed scale. I found that really helps with addressing a lot of issues as a systematic approach. I think it's great to having control and automation, utilizing that as much as you can, but also have a feel-safe plan. If there's a power outage, is there anything wrong? So what do you addressing with that level of risk? The last one, but not least, the maximize the data utilization to the fullest potential. You might have data source, let's say the weather forecast, only for your stormwater management, but that information could also help you to proactively doing process control for treatment plant. So how do you bring that data information to multiple areas to utilize it to its full potential is always beneficial to the overall district. And I think the Digital Solutions Group, that's what our role is, to really facilitate a lot of this connection and collaboration within the whole clean water services. With that, so really looking forward to this Q&A session, and thank you, everyone.
Great, thank you so much, Ting. Looks like we just got a question in, so I'll just go ahead and read it off. Are you able to run surface water routing models to simulate large storm events with the system? Also, are there any real-time water quality stations that provide real-time water quality data, such as dissolved oxygen and nutrient concentrations as part of the system?
Yes, we do, Savannah. So we do have a lot of water quality stations as well. So like a DEO, water, chlorophyll, and also some of the conductivity pH. And I'm also piloting a few additional water quality sensors currently. So that's a key area for us for the surface water. Regarding the modeling effort, yes, we do the surface water modeling, and also we have the SWAY model as well as the stormwater and sanitary sewer model as well. So for the modeling effort, right now we're still achieving, whether it's water qualities or whether it's collection systems, but the future is to getting this model integrated and on the watershed scale.
Great, thank you, Ting. If you would like to ask a question, please go ahead and enter that into the question and answer section. I think we'll just wait a minute to see if any more questions come in. All right, one more question here. Do you find the optical range gauges superior to weighing buckets or tipping bucket gauges?
Well, that's a pretty detailed. Our field crew probably could give more information if someone wants to contact me. But in general, I think we use the tipping bucket and also the optical as well. It just depends on where we are installing. Sometimes the tipping bucket, if something is like a stuck, then you don't get back to that stage. We are also working with the university professor, so they have also developed a new type that we are going to try. So that's right now on top of my head, but if you are interested, we could definitely follow up with the more different types and how we deploy it in different locations.
Great, thank you. And another question for you, have you looked into using a data lake?
Data lake. We are just started on the data analytics. I mean, having a team to do analytics. We have, you know, from the district, we have different business units, and also we have the expert to doing that. So we are just start to look into that right now. So I don't think we have utilized that yet, but it's just building that data architecture right now.
Great. And another question, what type of telemetry and communications are currently in use?
Currently, mainly is on the cellular network. And we also have a satellite network with the smart cover technology. We are exploring additional, there's a LoRa network and other cellular providers, and we hope to find some of the portfolio with the different networks. It really depends on how often you need the data for. For cellular, I see it's great if you really need that near real-time or real-time data, but it's also expensive. But for other parameters like soil moisture, we use it for stream restoration project. And it doesn't change that often from a project management level. And so we are exploring additional networks like LoRaWAN network for those type of applications.
Great, thank you. Someone also asked, how many watersheds are you all monitoring?
We have one watershed, 12 watershed, but we have a few subbasins. So there is the Fennel Creek subbasin. We have the Chicken Creek subbasin. So definitely we have more monitoring in the mainstream, and there are some of the limited monitoring in the tributary stream. It's all, we have that information if folks want to email me. But we are also want to expanding this surface water monitoring with additional low-cost open source IoT device. Because what I see is before you get this sensor package with everything, but now what I'm saying is you have the bare wear sensor, and then there is additional data logger and radios, the things that you could really assemble with the open source platform, which is getting much cheaper. We're doing a pilot on that, and hopefully that will expand our monitoring capabilities and the coverage.
Great. And another question, do you make use of any data collection or other support from citizen volunteers?
We do. This is definitely a part we have discussed internally. So we're just starting to working with the citizens, and they have a lot of data too. The question is, what are you using this data for? If you're using this data for design, then there is a data quality and things. But it's also, if you just want to bring this data in to really see what are the erosion information, the rivers, and we are looking to that and bring that in and understanding both the citizenship as well as the internal data to tell the whole picture.
Great. Someone also asked what kind of open source tools you guys are using.
We just get started looking to that. So like Adreno open source, and there is the other, like for visualization, there is a web mapping open source we are exploring.
Great. And how much ground truthing is done as part of the LiDAR surveys? For example, are impervious areas ground truthed on a regular basis?
Yeah, we look into that with the additional, what we already have, the land use and land cover data. So that's the LiDAR information mapping with the GIS existing database. So that's, we have done that initially. Once you've done that initially, build the confidence, it's really the second data, it's really, you can really using that directly.
Perfect. I think we have time for one more here. Have you utilized any lower cost quality sensors? And if so, how well do they work compared to higher cost commercial sensors?
I'm just in the process of testing them right now, so I can't really see right now, but I'm hopeful because I think it's very important to find additional different type of sensors. So I could report back probably in next year, early next
Great. Okay. Thank you, Ting.
year.
If anyone has any additional questions, is it okay for them to follow up with you directly using the email you've provided?
Yes, please do. I really hope to also hear some of the exciting stories what others are doing. So yeah, please do. I have my email here and the phone number. Feel free to call me or email me anytime.
Okay, perfect. All right. Thank you so much, Ting, and thank you so much for coming, everyone else. If you have any questions for Ting, please feel free to reach out directly to her. So thanks so much for coming.
Thank you, Savannah, for having me.
Thanks, Ting. Bye.
Bye.